Welcome to the chi-square test of independence. So we're going to look at an example and we'll follow the same example through all of the videos for module 27. So our example, a study was run to determine if there is a relationship between student status and major area at a college. So researchers took a random sample of 200 students and the data is recorded below. From that data, can we conclude at the 5% significance level that student status is associated with major area? So what I mean by student status is just if they're a full-time or part-time student, and the major area, they could either be in the natural sciences, social sciences, or humanities. Um, Often we refer to that as arts and humanities. So we have our two-way table here. So there were 36 full-time students in the natural sciences, 41 full-time in the social sciences, 31 full-time in the humanities, for a total of 108 full-time students. There were 21 part-time in the natural sciences, 36 part-time in the social sciences, 35 part-time in humanities, for a total of 92 part-time. And that left us with 57 total in the natural sciences, 77 total in the social sciences, 66 total in the humanities, for 200 students in total in the sample. So recall, we've seen these sorts of questions before. So back in module 10, where we first saw two-way tables, we talked about if two categorical variables were associated. So recall in module 10, we talked about checking to see if two categorical variables were associated. And the way that we did this was we looked at conditional probabilities. So we studied conditional probabilities. So for example, let's just focus on natural sciences. So that's our first column. So let's do if a full-time student is selected at random, what is the probability? They are majoring in the natural sciences. So here we are focusing on full-time students. So we're only looking at this first row. In that first row, there were 108 students to consider, 108 full-time students, and 36 of them were in the natural sciences. So we would do the probability. We have 36 in the natural sciences out of the 108 full-time. And if we do that and put it in decimal form, then we are looking at, one moment, 0.33. That's actually precisely a third. So basically 33% of full-time students in our sample were in the natural sciences. So 33% of full-time students in the sample majored in the natural sciences. And then we can do the exact same thing for the part-time students. So let me buy myself some more room. So if a part-time student were selected at random, what is the probability? They're majoring in the natural sciences. So again, scrolling up, this time around, we're looking at part-time students. So we're focusing specifically on the second row. So we had only 92 students to consider, and 21 of those were in the natural sciences. So we are looking at, we had 92 part-time students. And of those, 21 were in the natural sciences. I'm just going to check. Yeah. Okay. So if we put that in decimal form, we are looking at about 0.23 if we round. So in other words, 23% of part-time students in the sample majored in the natural sciences. So the question becomes essentially, when we pick a sample, we don't expect it to precisely match the population. So at what point are our conditional probabilities from our sample different enough for us to say, oh, then they're also different for the population? So the question essentially is, at what point are the conditional probabilities different enough for us to generalize to the population also having different conditional probabilities. So that's where the chi-square test of independence comes in. So we are used to having p-values where it's basically we can measure precisely the probability of getting a sample as extreme as ours if a null hypothesis is true. And we are going to have a p-value for this situation as well, so we can run a strict hypothesis test and have a clear cutoff point. So the chi-square test of independence, we will have hypotheses. In general, the null hypothesis will be that there is no relationship, there is no association. So there's no relationship, no association, or we could also say that the variables are independent. The alternative hypothesis will be that there is a relationship there is an association, or the variables are dependent. So in our specific example, our null hypothesis would be that there is no relationship between student status and major area. At the college. And the alternative hypothesis would simply be there is a relationship between student status and major area. So these are our hypotheses. And then in a test, our job would be basically to assume the null hypothesis and see if our sample is surprising. So then we will assume the null hypothesis and determine if our sample is surprising. Just like we usually do with hypothesis tests, and then we'll draw conclusions. So that's just the basic idea behind the chi-square test of independence. We will get much more into the details in the next videos.